Hi everyone, so today we're going to solve this problem called rotting oranges. In this problem we are given a grid and there are three kinds of values: 0 representing an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. And we are also given that if any orange is adjacent to a rotten orange, if a fresh orange is adjacent to a rotten orange, in after the current minute it will get rotten too. So as you can see here, the X marked orange is rotten, and at 0th minute only this orange is rotten. But at the first minute, the cardinally adjacent oranges to it also get rotten, and the process goes on. So from this orange, these two get rotten, and from this one and this one get rotten, and from this one gets rotten. So the first approach I can think of is breadth first search, because it goes level by level, and as we can see from the example, we are progressing level by level of the oranges. First we have one orange, and then we wrote all the oranges at the first level, then wrote all the oranges at distance 2, then at distance 3, then at distance 4, and so on. So what we need to do is we we can create a queue of all the rotten oranges that we have, and then start a BFS from each rotten orange and see how far we can get, and if we can rot all the oranges. And if we can't rot all the oranges, we have to return -1. Okay, so let's proceed with the idea. um, First we need a queue, and this queue will have the coordinates of the orange. Let's make a vector for that, and let's name the queue as rotten. Then we will traverse the grid. I is less than the number of rows, and I goes plus plus, and the columns, if I can type that, will start from 0, and j will go up till number of columns, and we will increment j, and we should also get the number of rows and columns first. So int number of rows will be equal to number of rows in grid, and number of columns will be equal to the number of columns in grid. Alright, so now that we have NN, NR and NC, number of rows and number of columns, we can say that uh, if the current orange is rotten, that means if the value is equals to 2, then we can put it in our queue. Rottens dot pushback, the coordinates of the orange, and yes. Okay, so with that out of the way, we can just BFS from all rotten oranges. Okay, so if we are doing BFS, then how do we get the answer? How do we know the number of minutes? The number of minutes will be equal to the number of levels that we traverse. If by the fourth level we have rotten all the available oranges, then we can say that 4 is the answer. And if we can't rotten any oranges at all, then we can return -1. In what case can we not rot all oranges? When the oranges are not connected. For example, if we're given this graph, you can see that only the top left orange is rotten. And if we write this, if we represent this in a grid 2, 1, 1, and then it's 0 comma 1 and 1, and then it's 1 comma 0 comma 1. All right, so you can see that no matter what oranges get rotten, we will never reach the lower left orange, that is fresh, because it is not adjacent to any other oranges. All the other oranges will progressively get rotten from the first orange, but not this one, because these two cells, the adjacent cells to it, are empty, means they don't have an orange in them. Okay, so let's continue with our solution. The number of minutes, int minutes, will be equals to 0 initially, and the answer will be equals to the number of levels. Okay, so let's just traverse. While we have rottens, we need to continue our BFS. We'll get the size of the current level, which will be rottens dot size, and then we will traverse all the oranges in the current queue, and we will check what fresh oranges are connected adjacently to the current rotten orange, and so we will also rot them and add them to the rottens queue. Okay, let's proceed. So int current x, the current coordinate of the current orange, the orange that is at the front of the queue. Its x position will be recorded in the current x variable, and similarly we can have a current y variable. It will have the y coordinate of the rotten orange. Let's just adjust the indexes. All right, so now that we have that, we can pop from the rottens queue, pop the current orange, and then we will start a for loop, and here we will add all the fresh oranges to the queue. Okay, so to traverse all the 4 directions, we create an array. And let's call it direction of x and direction of y, because we need to generate all 4 coordinates around one cell. So for example, if we have this cell, then we need the coordinates of this cell and this cell and this cell and this cell. The cell above it, the cell below it, the cell to the left of it, and the cell to the right of it. Okay, and how do we do that? We just say, if we let's start from left first. So if you're going left, our direction will be -1 for x, and for y it will be 0, and then we go up. So for x it will be 0, and for y it will be 1. Then we go right, and for right x will be +1. Let's just make it 1, and y will remain the same. And we have done left, up, right. Now we go below. So direction y will be -1 and x will remain the same. Now as you can see that the elements in these 2 arrays are quite similar. 3 of the elements are in the same order. So what we can do is, we can say, if you had another element here, this array would totally match this 3 elements would totally match these 3 elements, right? So what we can do is, if we just attach a -1 in the end of direction x, we can have x direction equal to ith value and y direction equal to I plus 1th value. So instead of using two arrays, we can just use one array, and let's just name it direction, dir for short, and now we have the directions. Okay, now let's traverse all those directions from 0, and we have 4 directions, and I goes plus plus. Okay, and here you want to traverse all the 4 directions. So the new row would be equals to the current x plus direction at I, and the new column will be equals to current y plus direction at I plus 1. And we will say that if orange at new row and new column is fresh, then add to the queue. Okay, and let's just convert that to code. If grid at nr and nc is equals to if it is fresh, if it is equals to 1, then we can add it to our rottens queue. And how do we add it? Oh, we okay, it should use push, not pushback. Pushback is a vector method, not a queue method. So rottens.push, and here we push the coordinates of this new fresh orange. And after this, we also have to say that this orange is also rotten now, since the minute has passed. This orange is also rotten now. Okay, so that works. But we remember that we also have to check if nr and nc are valid. How do I mean if they are valid? See, we are subtracting -1 and we are also adding 1. So we have to make sure that they are within the constraints of the number of rows and columns. So nr has to be greater than or equal to 0, and nc has to be greater than or equal to 0. Okay, I've actually reused nr and nc. So let's just name it differently, new r and new column. And let's just also change this one, new r and new column. This one too, new row and new column. And both should be greater than 0, greater than equal to 0, and the new row has to be less than number of rows, and the new column has to be less than the number of columns, and of course the orange has to be fresh. Okay, so that all looks correct. And after we have traversed one level, this part is one level, and after we have traversed one level, we will increment the minutes, and then we can just return the minutes. However, this will give us a correct answer. However, there are a few things to consider. Currently, the code does not check if all the oranges have rotten at the end of the minutes, at the end of the BFS. So how do we check that? Let's take a variable called count. Let's take a variable called count, and initially it will be 0. And if we encounter a fresh orange, grid I and j equals to 1, then we can increment count. And when we rot a orange, then we can decrement this count. Great. So here we can check if all oranges are rotten. If count is 0, yeah, if count is 0, we can return minutes, or the answer will be -1. Okay, that works. What else? What else are we missing? I think we're missing that uh, if if all the oranges are already rotten. Oh, no. I know. All right. So as you can see that we are starting at minute 0 and then traversing, and then the minutes progress 1, 2, 3, 4 in natural numbers. But we are starting from 0, which means that the first level we traverse will be at minute 1. But that shouldn't be the case. The first level should be traversed at minute 0. So we start at minute -1. Okay. With that out of the way, is there anything else we are missing? Is there anything else we are missing? Oh yes, we are missing another thing. If all the oranges are already rotten, then the time taken to rot all oranges will be 0. So how do we check that? So if minute just remains the same, if this never works, if this traversal never happens, that means the already the oranges are rotten and we don't need to add anything to the rotten skew, because count is already 0. All right. So how do we do that? We check if minutes is equals to -1, and if it is, then we can return 0. Otherwise, we can return minutes. Will this work? Let's check. Okay, there's something wrong. Reference binding to misaligned address. Okay, there's something wrong with the addressing. We are using a vector of int rottens nrnc is equals to this. Then what is wrong? I'm adding ing here. Rotten is not empty. I popped it. Then I'm traversing the 4 levels. Nothing seems to be wrong. It has to be equal to 1. Rot the orange here, and so what is wrong? Let me just pause once. Hey, so I found the problem I was making, the problem that I created. So the mistake is that here I'm using nrnc and I should rather use new row and new column, because nr and nc are the sizes of the rows and columns, and I was wrong to use them here. So we add new r and new c. All right. Is there anything else that is wrong? Yeah, and I was also wrong to explain that when minutes is equals to -1, we return 0. The complete thought process is that if minutes is equals to -1, either there are no rotten oranges, or that the rotten oranges, yeah, the idea is that there are no rotten oranges, so we can't rot any other orange. So the answer would be 0. Let's check if this runs. Yes, it runs. And to show you what I mean by this minutes thing, let's just eliminate this here first. Just eliminate this condition and try to submit. And you see that there are no rotten oranges, so we should have returned 0 because uh, there is no orange at all, so we don't need to rot them. And if we don't need to rot them, the answer would be 0 because the answer is -1 when we can't rot all the fresh oranges. I hope you understand now. So here we check if minute equals to -1, then we return 0. Otherwise, we can just return minutes. And let's try to submit. And it works. So the time complexity is number of columns into number of rows, and the only extra space we are using is the queue, and the queue can have at max all the cells of the matrix, which is of the size of nr into nc. So the time complexity is O of nr into nc, and the space complexity is also nrn into nc. But as you can see, we pop all the elements from the queue, so we might as well say that the space complexity of the queue is constant because at the end we are not occupying any extra space. Thank you.